So who's tried 729s? So 729, the sort of the thing with this one, if you look at 729, it's like female heterozygous for 3 recessive mutations, ABC, was crossed with a homozygous male, recessive, 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 just classic sort of 3-point cross, right? But when we look down at the phenotypes, we're expecting in a 3-point cross, we expect how many different phenotypic classes? How many total? Remember? In a 1-point cross, 2 dihybrid, 4 trihybrid, 8, right? If you weren't sure about that, just look over at 321. How many do you have over here? Or 721. 1, 2, 3, 4, 5, 6, 7, 8. All right, does everybody see that? Look back at the example in the PowerPoint. 8 different phenotypic classes that result. All right, so all of a sudden here we see, there's only 6 different phenotypic classes. So of all the phenotypic classes, and you look at the relative amount of what we expect on each of them, so the one that's going to be the highest incident is going to be what? Which one? What does that one tell us? That's a parental, or where no crossing over has occurred, right? So we see that 348, 306, right? So that tells us what, when you begin to do this problem, that tells you what the parental one is, right? So you got to look for the crosses, and the second thing that we do is we look for the double crossing over. But what do we know about the double crossing over? When we look over at the one on 721, what does that show us? That there have been 0 and 0 of those 2 on the bottom. Does everybody see that? That's because it's more rare to have the double crossing over. Same thing as occurs on 729, only what? They don't give you the 0 and 0. You have to figure it out. Okay, and you're gonna have to do that by process of elimination of looking at the other 2 and then say, okay. So that's the only difficulty with that one. It's just a little bit more difficult because you have to figure out those phenotypes.
You did, or like redetermine C's in the middle. Because Jackie had showed us the way that you had showed her to determine the middle.
Well, let's see. So well, should we do it then? All right. So let's just go. Let's just determine which one's in the middle. All right. So I'll have to write these up. So I'm going to write up the parentals as plus C, and the order is ABC, right? Yeah, ABC. Plus C is 348. What's the other most common one?
AB,
No, but what is it?
AB plus.
Oh yeah, AB plus 306. Okay, these are the parentals, right? And then what are some of the other ones? The one that is around 100. A plus plus, right? Is how many? 110. And what's the other one that's close to that?
Plus BC. And it's
plus
96.
BC. So
96.
you can see how I'm kind of grouping these. You're right, kind of by what their frequencies are. So 96, and the other one is plus and ABC. Plus, ABC. What's plus frequency? What is it? And then the other one? I guess it doesn't really matter because we're not going to do the math. But okay, so here, which one is missing? Plus. Do you see a plus B plus anywhere? Okay, so okay, plus B plus. We'll say is 0, right? So plus B plus is 0, and then A plus C is 0. Okay, so now looking at the parental here, right, and looking at the rare one here, this one is AB plus, right? Let's see, plus C, right? Plus. So in order for this one to be plus C, right? You would have if this one was plus C, We'll just write the parental right next to it so I don't have to keep looking up. So that's plus plus C, and this is A, B plus, all right? Looking at these and comparing them to those, which is the gene in the middle?
A.
A.
Not C.
Not
I
C.
can remember which one it was.
So there you go. So now you have it, and now you'll just do it the same way. You remember how you reorganize them or you reorder them. It's slow, it's cumbersome, but it saves, at least me. Maybe some people can keep it all straight in their brain. I can't. I have to reorder them and then look at it same way. So we already have it here. It's going to take us a little while, but then once we do that, it just turns into one of those simple sort of 3-point crosses that we've done a number of different times. All right, makes sense? All right. Okay, whose is this? Oh.